Here we go, work solutions for the SAC, practice SAC we just did. The ball is thrown with initial horizontal velocity and initial vertical. Okay, so they've broken it up for us. The launch angle of the ball relative to the horizontal. So this really is a trigonometry question. Oh, jeez. A trigonometry question. That's supposed to be a right angle triangle. Horizontal velocity is 4.7 meters per second. Vertical velocity 5.2. Right, so this is our vector diagram of velocity vectors. And relative to the horizontal, that's our angle in here. So we don't have any hypotenuse, so we have to use tan. Tan theta equals, tan is toa. Soka toa, tan is opposite over adjacent. Tan theta equals, opposite is 5.2. And adjacent to the angle is 4.7. So 5.2 divided by 4.7 is whatever it is, and then you inverse tan that, and you find that theta is equal to 47.9 degrees. Okay, question 2, at exactly 2 seconds after the ball has been released, so oops, time equals 2 seconds. Find the horizontal distance the ball has travelled from its origin. Well, we knew the horizontal velocity was 4.7 meters per second. And in the horizontal direction, acceleration is equal to 0. So it's going to be doing this speed of 4.7 meters per second all of the time. So if we're talking about a constant velocity, we can do V equals delta x over delta t. That's 4.7 equals delta x, which is what we want to find, delta t, which is 2.0, 4.7 times by 2 is what delta x is going to be equal to, and that is 9.4 meters. Question 3, the maximum height of the ball. Okay, so they did give us our vertical velocity, initial vertical velocity of 5.2 meters per second. Maximum height, at that maximum height, its velocity is going to be 0. Alright, so we're considering this sort of motion here, and I'll take upwards as positive, so the initial velocity 5.2 meters per second. That's at this point here, at the very top of its arc, that's going to be V equals 0, and the thing that's been slowing it down all that time is acceleration at negative 10 meters per second. Alright, accelerations are acting downwards, so therefore it has to be negative. And we want to know time. Okay, so V squared equals U sorry, we want to know X. I'm looking at the wrong question. We want to know X. V squared equals U squared plus 2AX. V squared 0 squared equals U squared 5.2 squared plus 2 times by minus 10 times by X. So 0 equals 27 plus minus 20x. Minus 27 equals minus 20x. Divide both sides by minus 20 and you get x equals 1.35 meters. Question 4. The ball lands on the ground 1.2 meters below the release height. So starts here, goes up, finishes here. The distance from here to here is 1.2 meters. And our initial vertical velocity was 5.2 meters per second. Again, I was calling this direction positive. Therefore, its change in displacement is 1.2 meters downwards, so that's minus 1.2 meters. and acceleration is minus 10 metres per second squared. And this time we want to know time. Alright, so x equals ut plus a half at squared. Alright, that includes our 4 things in here. X is minus 1.2 equals u, which is 5.2 times by t plus half times by minus 10 times by t squared minus 1.2 equals 5.2t minus 5t squared. Okay, now we can see we're at this situation where we've got a quadratic, and if you're like me and you can't do that, then you need to find an alternative way to solve this problem. And the alternative way is finding another one of our variables and then working backwards to find t. So my new question is, okay, let's forget t for the minute. Let me find out v. So VAXU, v squared equals u squared plus 2ax. V squared we don't know, that's our unknown, equals u squared 5.2 squared plus 2 times by minus 10 times by minus 1.2. Yep, v squared equals 27 plus 2 times minus 10 is minus 20. Minus 20 times by 1.2 is 24. So v squared equals 51. And so the v is the square root of 51, which is 7.1 metres per second. Now, I can use that to find t. So I don't have to use this formula where I end up with 2 t's. I can just do v equals u plus at. V 7.1 equals 5.2 plus minus 10t. So that should be minus 7.1 because that's travelling in a downwards direction. So again, plus 7.1 would indicate that it's travelling upwards at 7.1, which is not right. So 7.1 minus 5.2 minus is 12.3 equals minus 10t, divide both sides by 10, t equals 1.2 seconds. Alright, now we get to the next question, acceleration. Well, we've got a force time graph. What's the acceleration at 1 second? Alright, at 1 second. Oh, I can't draw a straight line with this. Alright, so we know that this girl is experiencing 10 newtons at this time. That's the force. We know her mass is 80 kilograms, and of her and the bike, and they're asking for acceleration. F equals ma, 10 equals 80 times by a, 10 divided by 80, so we divide both sides by 80, a equals 0.125 metres per second squared.